Hello. So now we'll be solving question number 8 from previous year problems, chapter Laws of Motion, phase 1. So this question came in 2001 in IIT exam. So let's see. It's also a good question. So a string of negligible mass going over a clamped pulley of mass. So we have this pulley and the mass of the pulley is given as n. Then this is a clamp. The mass of the block is capital M as shown in the figure. The force on the pulley by the clamp. So this is the clamp and which is supporting the pulley ultimately. So here what we will do, we'll make the FBD of the pulley. FBD of pulley. Because ultimately they are asking how much force clamp is applied on the pulley. So I need to make the force by clamp as an external force. So pulley I have to assume as a system. So how many forces acting? First of all, it is the mass of the pulley which is acting downward, which is mg. Then we have this string connected to the pulley at this side. So string will have a tension. So string tension will be acting at this point, it will be acting downward away from the point ultimately. The T will be acting downward direction at this point. And at the topmost point, again, the string is connected. So here the tension will be horizontally backward. Apart from that, this clamp will be applying a force onto the pulley. That direction we don't know. Since we don't know the direction, so what I'll do, the force by clamp, I'll take two components. So whenever there is an unknown force, the best way is to take the two components. One component I'm taking it as Fx and second component I'm taking it as Fy. The resultant of these two will be the net force. Now pulley is not going anywhere. So acceleration of the pulley is 0. Now let me balance it. So when I balance, Fx along the horizontal will be equals to T and Fy will be equals to small mg plus T. Now what is the value of T? Need to calculate that as well. For that, what I'll do, I'll make the FBD of this bigger block, capital M mass. FBD of capital M. So here there are only two forces, capital M acting downward and the T is acting upward. Acceleration here also is 0. So that gives me the T is equals to capital Mg. Now this T I can put it here. So I'll get Fx as capital Mg and Fy as small mg plus capital. That becomes small m plus capital M times of g. So they're asking about the force due to the clamp onto the pulley. That will be the resultant of Fx, Fy. So it will be Fx square plus Fy square, the whole root. So under root of m square g square plus small m plus capital M square g square. I can take g square common, then Fc will be g under root of small m square plus small m plus capital M whole square. This is the force applied by the clamp under the pulley. Now in this question, the critical aspects were these. How the tension in the string applied onto the pulley. One came downward, one went horizontal. This is a special point ultimately. Because whenever you see string connected to the pulley will experience the force due to the string, and that force will be coming in terms of tension. So how we have applied and how we have solved, this is something new we have learned in this question. Okay, it's a very nice question, and as you can see, the option D is the right option in this case. Not D. Option C is the right option. So capital M plus small m square plus small m square, and this G is outward actually outside. Okay, so I hope you understand. Thank you.